I decided that we should cover these fundamentals because, well, if you look at the channel, we haven't had a lot of things uploaded recently, but also nothing on the fundamentals anyway. We have had some basic, we've had some very specific tutorials on things like structs and enumerations, and also more advanced tutorials on how to make, for instance, a notepad application in C# WinForms. Well, that's great and all, but what if you are someone who doesn't have that quite down yet? So we're going to start with the absolute fundamental bare bones basics. And this tutorial should work if you are on a Mac, if you're using Microsoft Visual Studio for Mac. For those on Linux, you would probably have to utilize Visual Studio Code with the C# add-ons. For both Mac and Linux users, you may not be able to follow along completely. If you're on Linux, I might recommend actually that you use MonoDevelop instead of Visual Studio Code with the C# extensions, because that's probably more convenient to use. But whatever, I'm going to start this tutorial by we're going to start this tutorial by creating a new solution. Your solution holds your project or projects. You can have multiple projects in a given solution, and all it is a means of organization. So we're going to go to File, New, Project. You can press Control-Shift-N if you're on Windows. So I have Visual C# selected here. You probably will not see as much as I have here, so you're going to want to ignore most of this. If you're on Mac, you won't see .NET Framework, I don't think. You'll see just .NET Core stuff. But it's more convenient for me to do .NET Framework, so we're going to do .NET Framework. We're going to create a console application. You want to browse for a location, and within tutorials I'm going to have the solution called the solution name. In my opinion, the best practice is to have it different from the project name itself. I'm going to call this project Hello World Basics. You can name it whatever. I don't think you can get away with the space in the name. Okay, you can, but you probably shouldn't, so we'll do it like that. Console app, .NET Framework. Let's go. So hopefully this text is big enough for you to view. We have some basic structures already written for us and some using statements, but we're going to try to make this as simple as one can understand. So I have to go through each and every thing in here and explain it all to you. If you hover over this stuff, it'll say using directive is unnecessary. You'll understand what that all means later. So take a look at the Solution Explorer, which should be on your right, on the right side here. Solution Explorer. You can move this to the other side if you'd like. The Solution Explorer contains your solution and all your projects that are a part of that solution. Within the project, you have your properties, references, app.configuration, and program.cs. You can rename this program.cs by right-clicking on that and pressing rename. And in this case, we'll call this Hello World. Press enter. It'll ask us if we want to also rename the code, all references to the code element program, and we want to press yes. Otherwise, it may cause problems in the future. So there we go. And notice that it renamed our class to Hello World. So I suppose I should explain this. This line right here is namespace Hello World Basics. This is where the namespace Hello World Basics is defined in code. And notice that right after where it says Hello World Basics on the subsequent line, there is an opening curly bracket followed by a curly bracket right here, which is closing it. So for every opening curly bracket, you have a closing one. Now within this structure, within this hierarchy, there's another level to the hierarchy, a lower level, which is the class. So we have class, and the class's name is Hello World. Note, if you put a space in it, it will be kind of confused. It'll be like, there's a class named Hello, it'll be like, uh-oh, what's this? So don't put spaces in the names of identifiers. Hello World is the class identifier. Hello World Basics is the namespace identifier. Within the class of Hello World, we have another structure. This is called a method, specifically the main method. We're not going to go over what static or void means yet, but we will soon, so don't worry about that. And this string args thing, that probably doesn't mean much to you right now, but we will in fact go over that. So I put the insertion point right after this opening curly bracket. Press enter, and what that'll do is indent for you right here. And what we're going to do is we're going to write some code within this method, the main method, and it'll be what the program does. The main method is where everything in the program starts. All code that is executed starts within this main method. Main is required for every program in the C# programming language, in the same way that to my knowledge, every program in the C# programming language also requires a class to be contained within. You'll learn what all this means soon, but first, insertion point within this main method between the opening and closing curly brackets of main. Let's write console dot readline. And as you notice, you get a list every time you start typing something. You start getting a list. And this is for your convenience. You can press enter, for instance. There are other things done for your convenience, like when you press shift and then the opening parenthesis, it'll draw the other one for you and put the insertion point in the middle of those parentheses. This will help a lot. Now, write an opening and closing quotations, so put quotation marks. There we go. So we have two, and the insertion point is put between them, so it expects us to write something within that. So we can write hello world. Whoops. Hello world. Right after, you'll notice that there's a red squiggly line. It's expecting something. In this case, it wants a semicolon. So I should explain. As you can tell, class, our class is defined as hello world. And it's in this green color. Notice that console is also in this green color. What else does console and hello world have in common? Well, hello world starts with an uppercase letter, and so too does console. We're on to something here. And console and hello world are green because they are both classes. Someone wrote a class called console in a different place, and it is being used here. We are using it. In fact, we know it's being used, and we know where it's from. We know where console's from because we notice that this is no longer grayed out using system. So we know there is a namespace somewhere called system, and within that system namespace there is a class called console, and you know it's kind of it's like an address. Think of it like that. What happens if we were to get rid of system? Well, we can do that right here. We can go select all that, and we can I'm going to press Control X so it's not permanently gotten rid of. And as you notice, console, the program Visual Studio no longer knows where console is from. So if we wanted to fix this, we could write system.console.writeline. And now we know the full address, and this statement now makes sense. Now it knows where console's from. Now let's press Control V up here if you pressed Control X. We really only need using system. And notice how system down here is grayed out. It's because we're using system up here, so we don't have to provide the address for everything from system. Anyway, so console.writeline hello world. What this does, well, it takes our text and it writes it to the console. One more line. So I put my insertion point after this semicolon, pressed enter twice. I'm going to write console.readKey. You'll see why this is important in a moment. So let's press start. And it says hello world. It will write whatever we typed in there. So let's try that. You can put your name right here. My name isn't really Bob, but it felt fun to write. So you're going to press start again, and it'll say, my name is Bob. Cool. Now if I press enter, it'll close the program as well. So what does console.readKey do? Well, what it does is it keeps the program open so that it doesn't close by itself, and so that we can see whatever we've inputted before. If we get rid of console.readKey, if I did Control X right here while having it selected and then ran it, it would close instantly, see? It wouldn't even wait for us to see the thing. So let's put it back. Console.readKey. It's pretty important to have it when you're doing console applications. But this will not be the full extent of what we're doing here. What else can we display with WriteLine? Well, we can have it display text, text plus numbers. Fast way to run a program is by pressing F5 on your keyboard. I can put numbers in here, I can put symbols. And notice every time we launch the program, it automatically saves our work. We can have it show mathematical operations, right? Think about that. Could we? Makes sense, right? So what if we put in 7 plus 2? Well, it's just going to write it exactly as we wrote it because we're presenting it as a string of text. So if we want to actually do math, let's get rid of the quotations and write 7 plus 2. So it writes 9. It writes the answer to that question. It can do multiplication as well within that context. Minus 2. And we can also write divided by 2. It's pretty neat. Although, you might be thinking, hold on, 7 divided by 2, might that actually be a repeating number? So 7 divided by 2, that should be 3.5. Why is it writing 3? That leads us into our next part of the tutorial, variables. So instead of doing the math right within this method or function called WriteLine, we can do it right here. So we can create specifically a variable of type int. Int stands for integer, or a 32-bit integer. We'll get into that much later. So we could have a integer variable called variable, and we could have it equal to the result of 7 divided by 2. And then we could put the variable, for lack of a better name. Let's rename variable. Let's select variable, select rename, and then we can call it my variable. Press apply or press enter. And it very conveniently changes the name down here too. What happens if I didn't do that? What if this is like variable without an E at the end? Well, it won't know what we're talking about. It's not going to pretend to know what we're talking about. So we have a variable of type integer 32. We'll figure out what that means. It's a whole number. It's equal to the result of 7 divided by 2. So if we start, it'll still say 3. And that's not really good for us. We're like, can't we have decimal? Can't we have decimal parts? Can't we have like decimal numbers? So we want that. So what we would do for that, let's replace int right here with double. Now I'll run it. And it's still not quite what we want, is it? We're getting closer. Because if we look at this, it's a double precision floating point number. So what does that mean? Double can handle decimal points, but what we're still writing here is 7 and 2. 7 divided by 2. What do you mean? You might be thinking. What do you mean we're only writing that? Well, we're talking about 7 as an integer and 2 as an integer and the division of those two integers. What we're doing right here is performing integer division. We aren't performing decimal division. So if we want to perform decimal division, we have to go 0.0 after both of them, so we understand that these are in fact decimals we're messing with. So we can run, and now it says 3.5. Cool. So what it was doing before was something called integer math. Integer math says, I don't care about decimal points, I just want to have a general idea, not really focused with the decimal point. What it does is it chops off the decimal point. So what do I mean by that? Well, let's show another example, right? Numbers that are integers and numbers that support a floating point or a decimal portion, they have to be contained within their own variables. Let's make another variable of type integer, and we'll call this my integer. And we'll make it equal to my variable. Uh-oh. Cannot implicitly convert double to int. An explicit conversion exists. Are you missing a cast? So the part, are you missing a cast, is kind of the hint. But basically, we cannot store the value of my variable, which is going to be a decimal value, in my integer, because my integer is, by definition right here, a 32-bit signed integer. Integer variables cannot hold numbers with decimal part. So how do we fix that? Well, what if I want to force it in any way? What if I want to force this conversion to happen, as it was suggesting I could? Make some parentheses, type int, and then close the parentheses. So now what it does is it forces as much of the number as it can into this less complex number, this number right here, this variable that cannot actually support the decimal portion. Now if I press run, it's still going to say 3.5 because we didn't put my integer into the right line here. So let's put it in there. Let's see what happens to our number. It goes back to being 3. Because what this right here says is I don't care about decimals. Just chop off the bit after the decimal point and don't even show me a period or anything. Just do it. Just chop it off. Don't care. Let's destroy information for all we care. And that's what it does. And that's what we get. So, okay, so that's how we mess with numbers. And, you know, that's great and all. What if you want to get the square root of a number? And we'll quickly show that, and then we'll go on to the next important thing, which is more information about strings. So, let's create another variable. We're going to call this square root of 5. Notice that my variable names do not have spaces in them. It's because they cannot. Otherwise, they won't be recognized as a single variable name, you know. And also notice that every successive word in this bunched up variable name starts with a capital letter. I do that intentionally. That's called, in this case, camel case naming convention. It's a lot easier to read than if we did that, right? Do you agree? It's probably harder to read. And this is practice. This is something people do in programming. Alright, double square root of 5. If we want to get the square root of 5, we can call upon a method in the math class. We can type math dot, and we have a lot of options here. Someone defined a class called math, which is in itself part of the namespace system, and within that class we have all these different functions. So here's one called sqrt, which returns the square root of a specified number. That's awesome, right? So we can take this, and we notice that it wants an argument. If you are familiar with functions from pre-calculus or even trigonometry or algebra, you'll know that they require a function, or require an argument. Sometimes you can have multiple arguments for a given function or method in programming. In this case, it only needs one argument. So what we could do is put a variable. If we hover over it, we'll know that it only accepts a variable of type double. So we could put in my variable, and it'll accept that. Or alternatively, we can put in 5.7. So we'll get the square root of 5.7. Oh, wait, this variable says square root of 5. We should put 5 then. So we'll save. And we get 3. Oh, because this doesn't reflect... this is not the same as this, so we want this. There we go. Now we can run it. And it gives us the square root of 5. That's cool. That's amazing. Alright, let's talk about the thing we went over earlier in the program, which was hello world, right? So we were able to say console.writeline hello world. That's cool. Now you might be thinking, what if instead of 2 console.writeline statements, we just had one that said the same information? So I'm going to press cut right here, and right after this quotation mark, you're going to put a plus sign, and then press Control V, or however you plan on doing it, and then we'll get rid of this thing down here. Let's run it. And it just affixes or appends the value of square root of 5 to this string, this text. And we get that. So that's all the product of one line, which is pretty cool. Alright, other stuff. Let's let's figure out how to make a variable of type string, right? Because I've been alluding at strings. This is a string. This is a string literal. We are literally defining a string here. This is an integer literal. We are literally, excuse me, not integer literal. This is a double literal. This would be an integer literal right here. Just writing 6 would be a integer literal. Writing 6.0 or 6.1 or 6.7, that would be a floating point literal or a double literal. Anyway, we want to do string literals, so we can make a variable of type string called my name, and you can make it, or actually let's go with your name. We'll do that. That would be fun. And we can make it equal to quotations. And we can write, I assume someone in the audience is named Francis, or maybe Sarah. Perhaps Ada. Let's go with Ada after the first programmer. So we have your name equals Ada, and we can display that as well. We can write your name, and it'll just output whatever you wrote right here. That's cool. We can also affix this. What I wrote right here is an empty string, so there is nothing in it, and it'll look the same way. But I can add stuff. I can say, this is your name. And notice it preserves the spacing and the exact capitalization right there. So it says Ada every time. Now this is pretty cool. You can do a lot of things this way. You can keep adding parts here. We can keep going. We can keep going right here. So I made a space. And we can add your age, and we can put vary right here, this variable right here called vary, and it happens to be 6, but oh well. Of course, we don't have enough in the way of, we want to have a new line character, right? That'd be pretty nice. So what we can do for that, get this, to do a new line character, you put a backslash and then the letter N, and that means new line. So that puts it on the subsequent line, but we only used one console.writeLine statement. What if we want to have the program ask for a little bit of text and then manipulate that text in some way? So let's try that, right? Let's say it asks us WriteLine. Actually, we'll have it do write, so you can see how write works. Input your name. And then on the next line, let's say it's going to say input your name. So what does that look like? Let's see. Look at that. It's putting this blinking symbol immediately after it. Okay, so that's a hint of what we're going to do next. So if we want to actually grab the user's input and to save the input, we should do something like your name, which is a variable we defined up here. We're going to reassign the value of this variable to what the user writes. So your name equals console.read. Which one should we go with? So this reads the next character. This is also next character or function key. Or next line of characters. So what's a string, really? A string is, you can think of it as like a list of characters. A character is a symbol, like a letter A, or a number 1, or an apostrophe, or whatever. We just want whatever the user writes in this case. Now, readline can be used without putting in an argument. What are we saying here? Your name is equal to the result of console.readline. More on that later. Notice we don't do this with every method, right? We can't say your name equals console.writeLine. It won't allow us to do it there. And it's giving us a hint why. We'll get to that. Right now, though, we want to actually output what the user typed in. So this is your name. There we go. Start. Input your name. This is your name. Georges. I don't know. I don't know how to pronounce that. I think it's French. So we got this is your name plus your name. That's cool. What if there was a way to do this without doing the plus symbols? You're wondering. Is there a way you could do that? Yeah, actually there is. You can put curly brackets within these quotations, and you can say quotation mark, quotation open and close, so it looks like that. Then you can put a 0, and you're like, okay. Then you can put a comma instead of a plus sign. So you're like, okay, well that's great. Why do I care about that? It's going to look the same way, right? So I put in George's again, and it pretty much comes out the same way. Well, here's the thing, right? If you use this way, you can go like Control X and put it wherever you want. So it doesn't matter in this case where I have where this is at the end, because I can put this wherever I want. Now, what do you think 0 is? Why 0? 0, we count up from 0 in programming most of the time. And this, so because we count up from 0, the first variable included in this situation is going to start at 0. So the next one's going to be 1. So I can put in my integer as well. And if I want to have, if I want to put in that, I can. So second variable is number 1, and I can put that in there. So I can say Frank. 3 Frank. This is your name. Doesn't make a lot of sense, but it's kind of cool that we're able to do that. There's a third way that we can put variables inside of strings like this. So we can start again. This is your name. And right at the very beginning, just before the quotation mark, you can put in a $sign. And you can write another pair of opening and closing curly brackets, and you can write in here your name. So you can write Ada, and I'll write this is your name, Ada. That's cool. Which way should you go with? Let's go with the simple one that we learned first. This is your name. This way works fine. Notice that outside of the quotation marks, it doesn't matter if you have spaces. Like this. That's what I mean. Like if I have a space there and a space there, it makes no difference on the output. See? But when I have spaces in here, It does matter. Francis. I don't know what kind of name Francis is. I think I meant to write Francis, but whatever. So we've got all this stuff. That's pretty cool. We can go further, right? I mentioned earlier that you can have some functions give a result, and that's what this does, is console.readline. It gets what the user typed, and it takes that result and passes it, in this case, to this variable, your name. We can make functions of our own kind of like that. Now, the thing is about functions is you have to define them within the class or within a class, but not within another function or method. So we have to go to where the main method ends. So this is where it starts. This is where it ends, as you can see. Press enter. If we want to make a function of our own, let's try copying this right here, right? So we copy that and make sure it has an opening and closing curly bracket. Now it's going to complain about the name because there's already a member called main or method or function. So we can call this give name. Most of the time with methods, the method is named something with a verb in it. Main is one of the few examples of that not being true. We're going to learn about what static means, but not yet. Now, we don't know what string and then these brackets are. We don't know what that is. So let's get rid of this right there. And void is, we'll learn about that in a moment. So let's get rid of this stuff. And let's say we want to make a string called name equals the result of give name. Well, while it's true that there are no arguments required for give name, we cannot implicitly convert type void to string. So this right here is the only instance of where it says void. So what if we wrote instead of void string? Then this works right here, but down here it starts to complain because it says not all code paths return a value. What it means is that we have to have this method in some place of this declaration of the method actually use the return statement to return a value. In this case, a value of type string. So we can return we can do that. So we can say, oh, right. So while we gave name a value, well, we gave name something. Something went into name, but name was never outputted. So we should output name. Says your name. Cool. We can also directly put the method that we created called give name within the readline statements. We could write give name right here again. Remember, you have to have the parentheses. Every time you refer to a method, you have to have its parentheses. Even if there are no arguments, you have to do that. Oh, you're noticing a pattern here, right? This is reusable code. We can keep calling your name, or excuse me, give name, and it'll keep returning your name. Okay, that's really interesting. What if we wanted something that gives us a random number, right? It's all going back to random stuff. So let's have something that gives a random number. Well, what kind of number do we want? Do we want an integer or a double? I assume we want an integer number, so we can go static int. So this is going to be a method that returns an integer, and we'll call this get random number. And within this, we can make a variable of type random, and we'll call this variable, we could call it random with a lowercase r, or we could call it random rnd. So then we can, so we're like, okay, what do we make rnd equal to? I did control space so I can see the list of things we can make it equal to. But this isn't very helpful, is it? We're not sure how you create a random number. So you're going to have to bear with me on this, because this will be pretty different from how you're used to. You're like, I don't know how to make a literal random number. I don't know how that works. I don't know how to make it literal. You're going to have to bear with me on this, because random is an object, and we haven't quite gotten to what objects are. So we can go, yeah, so we'll figure that out in a moment. So we can go rnd equals new random. And we have to put parentheses. And we don't know what this construct is yet. We don't know what that is. But we'll go over that. Don't worry. And then if we want the actual number, we can create integer random number equals rnd dot next. So what we can do is we can say 0 and 10, right? So the minimum value and the maximum value. So it'll get us a number between 0 and 10. And if we want to return this, we can say return random number. So what is RND? RND is an instance of random. So what random is an object. An object is like a concept. Random holds the concept of what a random number can be, what a random number can do, what you can do with that. But if we want to use it, we actually have to, in this case, in the case of random, we have to create an instance of random that we called RND. And RND, in this case, is just going to be equal to a new instance of random. So we created a variable of type random, and it's just equal to a new instance of random. And then then we can access all the hidden secrets and treasures. Well, they're not exactly hidden, but we can access all the functions that are defined within this random class. Now, we didn't have to instantiate. This is what we did here, is we instantiated a instance of random. We didn't have to instantiate an instance of console, which is interesting to point out. We'll get to that. Don't worry about that. So we have a random variable, a variable called RND of type random, and we say rnd.next. So we called a method that exists only within the context of random, called next, and we gave it two arguments, 0 and 10. So that's the minimum value and then the maximum value. And then we returned that. We can simplify this code a bit. So to do that, let's put the insertion point right here. And we will just go and... So now we have random, RND equals new random. And then we take this and we do that. We can make this even more simple. So we can, if we wanted, we could say rnd.next 0 and 10. We could do that, and we could save so much space and all that by doing that. We could probably make it even more simple, but let's go back to how we had it before. This is great. This is great. So we're gonna use this method, get random number. Up here we're gonna use it. We're gonna say readline. My random number is, and then we can add a plus, and then we could write get random number. Make sure you put in the parentheses. And notice it got rid of the extra space, even though we could just have the space there if we wanted. See, that won't make too much of a difference. So our random number in this case is 0, 9, 5. So it is in fact random. Every time we run the program, we get random number between that range of 0 and 10 inclusive. So it also includes the 0 and the 10 as possible numbers, I believe. And like, I don't think can we get 10? Let's find out. So you might be wondering, okay. What happens if I copy and paste this line a couple times? It's going to be the same number each time. Get a load of that, right? What are we going to do then? That's not what we wanted. We wanted a random number every time. Well, the seed. How do we fix this, right? If only there's a way to make the machine that gets a random number sleep a little bit after we get the random number. Actually, I should explain how it actually makes up a random number. Because here's the thing, is computers aren't really random. It's all a trick. This random thing, it represents, in what it says, is a pseudo-random number generator. It isn't actually random. It just seems random. It's pretty random to us, but what it bases it off of is the current millisecond. And it does a little bit of math to it, and it gets a number. So the current millisecond on the clock. Well, if you call this quickly enough in rapid succession, it will, let's put it this way, it will continue to have the same number. So if we want to actually get a different random number every time we call it within a short amount of time, what we want to do is thread dot sleep, and then we'll put in 10 milliseconds. That should be enough. Of course, we're going to have to use using system.threading. So it writes that up here. And what that'll do is cause the program to slow itself down. It'll slow the program down a little bit. What it'll do is cause the program to stop for 10 milliseconds. So it goes from 2 and then go 5, 5, 5, 5, 5, 5. Because, well, that's the only time we've called it. Okay. So as you can see, we've got our method that returns a random number of our choice. What if we wanted a method where we can put in exactly what we want? Because right now it's whatever we wrote here. So what if we had int minimum? Oh, you're starting to see what I'm seeing, right? So we can take. So what is this? This is called an argument. Although in this context, really it's a parameter. It's a parameter. It's a parameter. And we can take this parameter, instead of writing 0, we could write minimum. So minimum is going to be equal to whatever we put in. So as you can see, it's complaining because we didn't put a number in. So we have to put in a number. So I'm setting the minimum number. Oh, wait, -0. Let's not do that. We don't want to find out what that looks like. So the maximum number is still going to be 10, but we've got ourselves some minimums. So that looks pretty cool, because now we have different possibilities for our minimum random number? What if we want to do a maximum, but also keep having a minimum? Well, we can do comma and then int maximum. And then down here, we can put maximum. That's neato. Here we go. Oh, it's still complaining. Up here we want to fix that. 1 and 3. Look at that. Isn't that better? That's pretty cool. So we've covered how to make methods that return a value, in this case a integer, and in this case a method that returns a string. Now how about one that is like this, where it doesn't actually... We gotta understand void, right? What the heck is void? What is void? Let's understand void. So let's create a static void do something, anything, really, please, just do something. So if we write return and then put a number, it won't like that. If we do a string, it also will not like it. What if we just leave it alone, just have return? What return will do in this case is just close out of this method. So that's kind of unexciting. What if we had return up in this right here? What if we put return within the main method? Main is also void. Oh, here's something you'll see. Unreachable code detected. You see, what return will do is just close out of that method. Having it in the main method, because main is the entry point, what do you think will happen? Let's find out. It just closes the program. Because main is the entry point, it's where the program is born, this just kills the program. Makes sense, right? So down here, do anything. Really, please just do something. Do something, anything really. Please just do something. This big method right here. We cannot return a value because that's not the point. It's not supposed to return a value. Not supposed to return a reference to a variable. It's not supposed to return the value of a variable. It doesn't return anything. But we can have it do other things. So it can do stuff like this. Of course, it doesn't show anything right there because we didn't call this method. So if we want to do that, let's copy that. And oh, we need to have the parentheses, of course, because it still needs its parentheses because it's a method. So now it says hello, 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 twice. It does that twice. That's pretty cool. Here's another thing we could do. We could do console dot beep. You'll find out what that does in a moment. Make some beeping sounds. That's nice. If you didn't hear that, I'm sorry, but you probably did hear it. And for that, I hope you enjoyed that. Right? So that's pretty nifty. So every time it calls this, it's going to write this stuff. And then it's going to say, it's going to beep. It's going to make the console beep at us. That's pretty cool. All right. Here's something, right? So you notice within this get random number, we define two variables. We define one called RND and another one called random number. We also kind of have minimum and maximum. What happens if we try to... well, let's see what happens if we try to display the value of minimum down here. it doesn't know what we're talking about. It says the name minimum does not exist in the current context. Well, we're in the context of main, right? This is the current method, but we never defined minimum within the method main. It doesn't exist. It exists only within the context of getRandomNumber. It has what we might say a different scope. You see, the variables that exist within getRandomNumber are different than the ones that exist within main. We can't, in getRandomNumber, say name. It won't know what we're referring to. It doesn't know what that is, because name is defined within main, but it doesn't exist within getRandomNumber. So we can't also reference it there. What if you want to have a variable that you can see throughout the entire class, regardless of the method? Well, you can do that. So right before main, or right after main, for instance, we could, between where methods are defined, you can create something called a class variable or a class field. So you can go int my car's age, and we'll make it equal to 7. That's neato. Now this is fine. This will work. Like, I can reference my car's age. Aha! So it's a non-static field. So we have to put static in front of it. In the same way, we have to put static in front of these methods. We'll understand more about what static is. So now we can write my car's age. We can change the value. Woot. And down in do something, anything really. Please just do something. We can write the value of my car's age. I don't have a car, but it's a hypothetical. So it says 88. Oh, that's neat. I can also change the value of it. I can say my car's age equals my car's age minus 1. So notice that every time we call do something, anything really, please just do something, every time we call that, it actually decreases the value of my car's age. Oh, that's neat. Now, here's something, right? What if we took this, transplanted it, got rid of it out of the class, just put it in here, and then got rid of this up here. So now int my car's age equals 7 only exists within the context of this, right? What happens if I subtract 1 from it then? Ah, look at that. So methods are kind of like blueprints. And when you call a method, what you are calling is that blueprint. You're not calling the previous iteration of that blueprint. It's static. But not only that, but it's redefined every time you call the blueprint. It doesn't store these variables. Do not exist within the class. They exist only within their specific variables in this case. So that's really interesting, right? That's fantastic. Now, one more thing before I end this video. It's gotten very long. Is pi. Let's create a variable called my pi, and we'll make it equal to math dot pi. Oh, so here's an interesting thought. Pi is a variable. It's not a method. We know it's not a method because we don't have to put parentheses after it when referencing it. But it exists within the class. So what can we infer about pi? Well, what we can infer is that it was defined outside of a method. Someone made a variable. Perhaps it was of type public. Perhaps it was read-only, because I can't actually I can't take pi and make it equal to pi minus 1. I can't do that. It won't let me. It does not like that. But I can make my own version of pi right here, and then subtract from that version. I can do that. That's fine. But what can we infer about pi? Well, we know that it was defined within the context of a method. So someone went and said, okay, I want a double pi, and it's equal to 6. You can do that. It also wants you to make it read-only. And this is a constant, but it's not read-only. You'll understand what read-only and constant mean. But read-only basically means you can only look at it. You can't change the value. And constant means almost the same thing. There is a slight distinction to be made, but we're not going to talk about it in this episode. But I can refer to pi. Oh, that's interesting. I can't just refer to pi because it's confused. What if I did hello world dot pi? Oh, it can't because this has to be static as well. There's only one pi within this class. There's only one pi. In the same way, there's only one pi within the math class. That's what static means. There's only one. There can only be one. Just like how there's only one main, only one give name, only one get random number. We can call these things multiple times, but there's only one blueprint for it. So now, because there's only one pi within Hello World, I can get away with saying pi now. We can subtract 4 because it's not constant. If I want to make it constant, I have to go static const double. Whoops. I think it's static double const. I always get the order of those mixed up. Nope. Never mind. We're not going to cover that yet. Anyway, that's it for today's episode. I think you've learned a lot. We're going to cover objects in the next episode, and everything about objects you might want to know about. And the difference, of course, between primitives and object types. I'll see you then.